Welcome guys and girls to this lecture. So there is a lot of confusion around how does container scale. So in this video, we are going to go deep and understand how it does. So we are going to take a quick look into EC2 scaling because then we can compare and understand a little bit easier. Then we are going to take a look at container scaling. We are going to understand pod limits and requests. And then we are going to go deep on horizontal pod autoscaler. And then we are going to understand a manifest file. And then we are going to do a HPA demo. All right. So we have a lot in our plate. Let's get started. Let's start by looking at our traditional EC2 scaling. So we have an application load balancer pointing to a EC2 autoscaling group. And the autoscaling policy is the EC2 will scale if the CPU is greater than 50% based on CloudWatch metrics. So we are assuming some traffic is coming in. We have this single Amazon EC2 M5 large running and the CPU is around 30%. Now let's say traffic increases and the CPU for that Amazon EC2 becomes, let's say, 60%. So that is beyond 50%. So what's going to happen is it's going to provision another Amazon EC2 M5 large within the autoscaling group. And then the load balancer will start distributing the traffic. And the CPU for the first Amazon EC2 will go down to 30%. So basically the autoscaling group will keep the CPU utilization at or below the specified 50%. Now, let's take a look at EKS container scaling. So in EKS, one node is basically one Amazon EC2. So if we abstract the Amazon EC2 part, so how a Kubernetes flow looks like is the traffic coming to a service, and that service is sending the traffic to a node, which is basically the Amazon EC2. And within that node, the pods are running, and within that pod, we are running the application container. And then a deployment object can deploy this pod. And let's say some traffic is coming in, and then the pod CPU is at 30%. So this is one big difference between the EC2 scaling and container scaling. EC2, we measured the metrics of the whole EC2, but in container world, we can check the CPU for each individual pods. Keeping that in mind, let's introduce this HPA resource or horizontal pod autoscaler. So as the name suggests, this is responsible for scaling the pod. And similarly, like EC2 autoscaling group, you can put a scaling policy like, hey, scale pod if pod CPU greater than 50%. So let's say some more traffic comes in, and then the pod CPU becomes, let's say, 60%. So what this HPA gonna do is create another pod. So this will try to keep the CPU utilization of the pods less than or equal to 50%. So once another pod gets spun up, the service is start distributing traffic to this new pod, and the CPU for the original pod will go down to 30%. So I know what you guys and girls are thinking. What if traffic keeps going up and then this EC2 or this node has maximum number of allowed pods? So there could be no more pods possible in this node. What's going to happen then? So what's going to happen is then another kind of autoscaler will come into play. So like HPA or a horizontal pod autoscaler works on the pod, we have cluster autoscaler which works on the node. So cluster autoscaler at that point will kick in and create another node or another Amazon EC2. And pods will start to come up in that new EC2. And traffic will start getting distributed, and the original pod CPU will go down to 30%. However, in this video, we are going to go deep on the horizontal pod autoscaler, and we are going to look into cluster autoscaler in a separate video. Okay, so going back to horizontal pod autoscaler, let's now take a look at an actual manifest file and see how they are defined. This is a sample deployment file. So most of it is familiar, right? Also make sure you watch the video where we go deep on the deployment manifest file and understand each component. So this kind deployment creates a deployment object. This replicas one create a replica set, and these containers create a pod with this specific image. However, this resources part is new. The requests CPU and limit CPU. So let's try to understand what they mean. Okay, so this container spins up a pod, and this pod is running on a node or an Amazon EC2, which is M5 large. I know you guys and girls are probably thinking, why does Raj keep on mentioning M5 large? Okay, here is the reason. This M5 large has 2 vCPU and 8 GB of memory. And 1 vCPU is equals to 1000 M or 1000 millicore. And this is an absolute unit. So let's say you are using M5.16x large, which has a 64 vCPU. Even there, 1000 millicores is 1 vCPU. Okay, with that in mind, requests means one pod when it's coming up requesting CPU of 500 millicore or half of 1 vCPU. And the limits mean even if the load increases, that pod can use up to 1000 millicore or 1 vCPU. So this is a good way to restrict pods in certain limits. And if a pod goes above, let's say this 1 vCPU or 1000 millicore, Kubernetes will terminate the pod. And there's another way to code this in the manifest file. Sometimes you will see this requests on the right side, CPU is 0.5. So it's basically in percentage. So 0.5 is half of 1, so basically 500 millicore. And the limit CPU 1 means 100%, so basically 1000 millicore. However, the left side manifest file is exactly gonna do the same thing as the right side manifest file. So it's up to your preference. I personally prefer these absolute numbers, but if you prefer this percentage notation, feel free to use that as well. Well, you guys and girls are probably thinking, okay, so that was CPU. How about I want to limit the memory as well? You can do that too using this resources section in the manifest file. So as you can see, this pod is requesting 500 millicore of CPU and 256 megabytes of memory, and the limit is 1000 millicore of CPU and 512 megabytes of memory. So this memory unit MI is similar or close to a megabyte. So here is the conversion. 1 megabyte is 1.04 megabyte. Basically, megabyte is based on 1000. So basically, 1000 megabyte is 1 GB or GB byte. I don't know how to say it. And 1 gigabyte is 1024 megabyte. But for our purpose, you can think of it as same. Because all the memory for the EC2 is actually given in GB bytes and not gigabyte. Okay, so this is how you can restrict the pod with the CPU and memory. But for simplicity, for this lecture and the demo, we are just gonna use the CPU. So till this point, there is no HPA. These are just requirements on the pod side, right? But there is no scaling policy, there is no scaling requirement so far. So for HPA, we need to code it in the manifest file as well. So as you can see, the kind of HPA is horizontal pod autoscaler. And how do we tell this HPA to manage this specific deployment? So it does it using this kind and name. So the kind is deployment, and it's managing the deployment with name PHP Apache, which matches the deployment name on the left side manifest file. So this HPA is gonna work on this deployment. And next is this target CPU utilization percentage. We are setting it as 50 or 50%. So now this part, let's dive deep a little bit. What it's gonna do is, it is gonna create a replica of the pod if pod CPU is greater than 50% of request CPU. So let's think about it. The requested CPU of the pod is 500 millicore, and 50% of that requested CPU is 250 millicore. So anytime this pod exceeds CPU utilization of 250 millicore, this HPA is gonna spin up another pod. And using this min replica and max replica, you can control up to how many pods it will spin up. So maybe you don't want this to spin up like thousands of pods, right? So the min replica 1 means it's a minimum number of pods it can spin up is 1, and max replica 10 means the maximum number of pod it can spin up is 10. And one funny fact is the replica set on the deployment is 1. However, when HPA kicks in, it actually changes the replica in the deployment and it increases it. So the number of pod increases. Similarly, when the utilization goes down, the HPA controls the number of replicas, it decreases it, and the number of replicas go down. And we are going to see this in the demo as well. Okay, so with that knowledge, let's jump into a demo. So a couple of things to keep in mind. Remember, for EC2 Autoscaling group, you have the CloudWatch metrics, but that only works for the node, which is the EC2. For pod, you need to have another tool called Kubernetes metric server. So for this demo, we are going to install it. I'm going to show you how. It should be out of the box installed for the EKS cluster, but I don't know why it doesn't. Okay, but anyway, after we install the metric server, we are going to deploy our deployment service HPA, and then we are going to increase the load on our pods, and we are going to see HPA take over, and we are going to see how HPA starts scaling the pods. One thing to note, the demo I am running in m5.large. Two reasons. One is all the theory I showed you using m5.large, so it's kind of consistent. Secondly, since we are scaling up to like 10 pods, T3.micro can only have a very limited number of pods, so it's kind of inconvenient. If you still want to use T3 micro, make sure you spin up a cluster with like 6 or 7 T3 micro worker nodes. But for this demo, I am using just 2 M5 large nodes, and I'm gonna shut down the cluster after this demo is over. And I'm using the image and the deployment file from the Kubernetes documentation. So basically, let me show you. So this image, this HPA example, so it basically runs this loop which puts some load on your pod CPU, and then we're gonna hit it. So I get the link in the slide. All right, let's jump into the demo. Okay, I have this EKS cluster spun up using EKS-CTL, and let's run kubectl get all. Okay, you can see there is nothing installed. World's most boring cluster. However, things are gonna get spicy. So let me clear the screen. So first things first, we are going to see if the metric server is installed. So if you run this command kubectl get deployment metric server in the kube system namespace. So okay, no metric server found. So this is how you deploy the metric server. You just run this kubectl apply from this github.com, and you can see it created the metric server. So if I go back and run this get deployment metric server, okay, now we can see the metric server is running. Next, we are going to deploy our manifest file. Let's take a look at that. So it's the same manifest file we went over in our lecture, deployment with the resources, requests and limits, and then we are installing a service, and then this horizontal pod autoscaler. Nothing out of ordinary, and I put all the manifests for individual components in one file, and you use these 3 dashes to separate if you want to put multiple objects in the same manifest file. Okay, let's deploy that. kubectl apply -f HPA dash. Okay, HPA PHP Apache.yaml. Let's do it. Okay, it's created. Let's do kubectl get all. Okay, you can see container creating, things are coming up. So it does takes a couple minutes for everything to come up. Okay, so one pro tip. So you can see it created this horizontal pod autoscaler. The reference is deployment/PHP Apache. And see this targets fields, how it says unknown/50%. So this 50% is from the target CPU percentage in the HPA file. So till this HPA is installed, you will see this unknown, and it takes a couple minutes to go away. Also, if you don't install a metrics server, this will stay unknown. So it doesn't matter how long you wait, you will never see a percentage. Because basically the percentage, instead of unknown, you should see pod CPU utilization percent. All right, I'm gonna wait a couple minutes and then come back and rerun the command. Okay, so a couple minutes have passed. So let's try it again. kubectl get all. Okay, now you can see the targets on the HPA is 0%/50%. Okay, so everything is up and running. So now we are going to create some load. So I'm actually going to open another terminal because I'm going to run something in bash mode. So I won't be able to input any more commands. So in this terminal, I'm going to create the load. And in another terminal, we are going to see how things are happening. Okay, I have another terminal open. Let me go back to the original terminal. And again, I'm following this Kubernetes reference manual because I'm using their image. Okay, and this is how I'm going to increase the load. So I'm going to copy this, and then it will get me a bash prompt. Okay, and then I'm going to run the load generator command. So basically, I'll keep on generating the load. Okay, let the magic begin. Okay, here you go. So I'm gonna switch to the other terminal and see what's happening. Okay, so let's run kubectl get HPA. The targets is still 0, min pods 1, replica is still 1. So it takes a few seconds for the CPU to spike up. Okay, so it's happening. So the target CPU went above 50%, so it's 64% now. So you will see another replica come up. So let's run kubectl get rs. So remember, I told you HPA actually goes and changes the value in the replica set. So even though in the deployment file, we created the replica set with 1, you can see HPA is changing it to 2, and then soon it will be even more. So if we do kubectl get pods, see, instead of 1 pod, now you have these 2 pods running, and we have this load generator which is generating the load. Okay, let's let it run for a few more seconds, and then I'm going to rerun the commands. Also, one thing to note, the default HPA check interval is 30 seconds. You can change it, but for this demo, I'm going to keep everything as is. So you might have to wait a couple minutes to see things really ramping up. So, okay, let's run this, get HPA. All right, so we can see we are at 5 replicas now. So again, let's check the replica set. And you can see the replica set values, the HPA changed it to 5. From 1, it went to 2, and now 5. Let's do kubectl get pods. Okay, so you have 5 pods running. So now what I'm going to do is I'm going to reduce the load. I'm going to stop the process, and this should scale down. Okay, I'm going to do Control-C, and then type exit. Okay, session ended. Gonna go back to the other terminal. So for the downscale, actually takes a little bit longer because the default value for downscaling is 5 minutes. So basically, the Kubernetes will keep on monitoring the CPU utilization, and only when it's down for 5 minutes, then it will start scaling down. The reason is, let's say it's scaled up, and then your traffic is reduced for a minute, but then it picks back up. This cooldown period prevents Kubernetes to just scale down, scale up, scale down, scale up. However, you can change all that, but for this video, I'm keeping everything as default. Okay, so if we run kubectl get HPA, it has not been 5 minutes, but you can see the targets, the CPU targets went down. It's 0%/50%. So as soon as the 5-minute marker hits, you will see the replicas will start coming down from 5. Okay, I'm gonna pause the video and come back after a couple minutes. Okay, a few minutes have passed, so now I ran the kubectl get HPA again, and you can see the replicas went down to 2. So if we run kubectl get rs, so again the numbers went down to 2. So if we run kubectl, let's say kubectl run get all, okay? So you can see the number of pods went down to 2 as well. So anyway, in a couple more minutes, the number of pods will go down to the mean pods, which is 1. Okay, guys and girls, that is the video. Everything back to normal. And if you're using M5 large, you can run ekctl get cluster, and then you should see the name of the cluster, and then you should run ekctl delete cluster name equal to the name of your cluster. This is an auto-generated name, in case you were wondering. 6652869. Enter this command and it will go delete the cluster, so you don't have to pay for the M5 large. But I'm gonna run a few more things for future videos. But anyway, if you are done testing this, please delete it if you are using M5 large. Alright guys and girls, that is the video. If you like the video, click the like button, smash it if you're into that kind of stuff, and subscribe. I have a bunch of other helpful videos on AWS and how to switch your career. Check them out. Alright, I'll see you guys and girls in the next video. Bye.